Hello children, this is your Shaktivel Max teacher. Welcome to our Vidya Lashmi YouTube channel. Today what we are going to see, chapter 1 sets, exercise 1.2 complete solution we are going to see. Okay, already we have uploaded exercise 1.1 which means set introduction and complete exercise 1.1 solution we have uploaded. I will give that link also in the description, you can see. Okay, now let's start the second means 1.2 introduction and the exercise. Complete solution we'll see. Before going to that, what is the empty set? What is empty set? We are going to see in the, what is that exercise? Now see children, a set which does not contain any element. There is a one set, my dear. In the set, there is no element. There is no element contained in the given set. Then that set is called the empty set. What we can call it? Empty set, or null set, or a void set, which means, example I will give. Example, set A is equal to, what I am going to write, set A equal to x, such that x is what, number 7 when a die is thrown. A die is thrown, I will write. A die is thrown. Okay. So if I write like this, see children, in a die the numbers are from 1, 2, 3, 4, 5, 6. That's it. 7 and all we cannot able to get when you throw a die. Okay. So this is what we can say is a empty set. Means nothing we are getting. Then A is equal to, when you write in the what is the roster form, nothing you will be getting inside. Nothing means you should not mention 0. 0 if you write, that is also countable, one of the element we have inside. So nothing means inside the bracket don't mention anything. That's it. So this is the way to write a empty set. This is the even symbolic form also we can mention. This is the symbolic form. When you mention the empty set, they have mentioned. And one more you can use what now? Pi. Okay. Like this they will be mentioned. Or pi. Pi means that meaning is empty set we can use. So empty means a set do not contain any element in the given set. That is the meaning. Example I gave here. Suppose x is the number 7 when a die is thrown. In the sense, when you throw a die, you never get a number 7. So that will be called a empty set. Okay, right, fine. Next we will go. Next we will go finite set and infinite set. Finite set and infinite set, in the sense, what it mean na? A set contain finite number of element is called a finite set. Otherwise, which is called a infinite set. That's it. Means, example I will give. Example what na? Set A is equal to, I am giving like a even prime number. Okay, even prime number I will give. Even prime number. X is even prime. Even prime number. So even prime number we know there is a 2. Number 2 is a even prime, only one number. Okay. So that which is equal to 2. So this is a countable. Actually finite means very easily we can understand when we have a last number or countable terms, in the sense we can say that what is that? Finite. Okay. See, they are telling a set which is empty. Even empty set also we can say finite set. Consists of a definite number of elements. Definite number of element in the sense, countable number of elements or last term, like that you can say. Understand? So this is the finite set. Suppose like a empty set also we can say, no, like last example what I gave for empty set, that also you can take, which means number 7 when you throw a die, that is also will be a finite set. And here number 2 is a finite set. Few more example I will give. So that 2 is equal to x, such that x less than or equal to, I will give like 0 less than or equal to x less than or equal to 10 and x divided by 2, like that. 2 conditions should be satisfied. So it should be, or else one condition also we can get. That is our wish. So when you write, what you will be getting from 0, 1, 2, 3, it's going till number 10. Till number 10. This is the finite set. Finite set means there is a last number and first number. So this we can say finite set. Infinite set in the sense, otherwise the set is called infinite, which means there is no last terms there. There is no last term. So that we can say as a infinite set. So infinite set in the sense what we can say, set A is equal to x. X is multiple of 5. What, my dear? Multiple of 5. So multiple of 5 in the sense, beginning number we know that is a 5, but ending number till we can write whatever you need. Understand? So that there is no end for this. There is no end for this. 5, 10, 15, 20, it's going on. Dot I'm giving. Okay, it's going on. So that type of set is called a infinite set. Suppose if you have a last term na, that we can say finite set. Have you understand? Right, fine. Let's go to the next. Right, equal set. Equal set in the sense, equal number of sets we have, or else same numbers we have in the set. That is also we can say. For example, A is equal to, example I am giving, A is equal to, I have 2, 4, 6, 8, and B is equal to 8, 4, 6, 2. Like this if we have na. See, there is a number from small to big I give. But here I didn't follow any order. Understand? First big number, next some other number I give. But if you arrange according to the order, 2 is there, here also 2. 6, here also 6. And 4, here also 4. 8, here also 8. So what are the number we have? Same number we have there also. And these things is called a equal set. Same number of element if you have in both the set in the sense, that we can say as a equal sets. What they are telling, two sets A and B are said to be equal in the sense they have exactly same element, exactly same element in both the set. That is called the equal set. We can write that as A equal to B. Example you can take like this. Otherwise set the sets are said to be unequal. Suppose second example. Okay. Suppose a second example, here I am giving example 2 is equal to, if I take A equal to, what is that, 1, 2, 3, and B is equal to same 1, 2, 3 we have, extra one element if I write here, extra one element if I write here, A and B are not equal, because there is a one more element here, so that is not equal. So equal differ from unequal. Understand? Exactly same number of elements if we have, that we can say as a equal sets. Okay, next we are starting the exercise ma. Okay, exercise. So these are the definitions which we need, already I gave. So equal set means what, finite infinite set means what, and one more what, empty set. What, my dear? Empty set. So totally three concepts we have seen today: empty and finite, infinite, and equal set. These things only we are going to face in the exercise 1.2. Okay. So which of the following examples? Null set. Which of the following examples are a null set? Null set means empty. What is the example? Is a empty they are asking, right? Odd natural number which are divisible by 2. So this is natural number they mentioned. Odd number means 1, 3, 5, it's going on. These number when you divide, when you divide by 2, you will be getting only in decimal, means in a point you will be getting. If you divide 1 by 2 means 0.5. 0.5 does not belongs to natural number. So here you will be getting empty. Here you will be getting empty. Okay. And a set of even prime number. Even prime number we have. Number 2 is a even prime. Number 2 is a even prime. X is a natural number less than 5 and more than 7. But at a time, this is never satisfy, right? A number should be less than 5 and more than 7. How it will be? When you draw a line, you comes to know there is number 5 here, 6 here, 7. Number should be less than 5. That X must be less than 5. Now here it will be. This is satisfied this side. At a time, more than 7 means that will be this side. Our same number will be less than 5 and more than 7. That is false. So such number we don't have anything. Then this will be empty, nothing. Okay. And y is a point. Y is a point common to any two parallel line. Common to any parallel line. There is a one point. There is a one point. Y is a point they are telling. There is a one point. The point must be common to the any two parallel line they are telling. That is also what, my dear, empty, because one point never be what is a parallel line? That will be intersecting line only. One point common to intersecting line. But parallel means you have to draw like this. How this point will be common for both the line? That is also empty. Okay, so you have to think carefully. So this is alone null, not a null set. So second point alone not a null set. Other first one, third one, fourth ones are a null set. Null set in the sense what I said, empty set. We understand, children? Right. Next we are going to, what is that? Question number 2. Which of the following sets are finite and infinite? Finite means what I said, pa. Finite means what is that? A countable number must be there. And infinite, na, there is no end point. Understand? So set of, what is the set of months of a year? That is the 12 months. So this will be finite. So if you have a countable means we can say finite. This is a finite. 12 months we have, so that we can say which is a finite set. See, there is a dot dot given, means this is a natural number. There is no end, it will be going on. So that if it is going no end point, na, we can give infinite set. What, my dear? Infinite set you can give. And here last point is given, first point also given. So this is also what, my dear? Finite. Finite means last point is there, na, we can give finite set. And set of positive integer greater than 100. Greater than 100. Past integer greater than 100 means 101, 102, it's going on dot dot. Okay, it's going on. There is no end for this also. For this also no end. What they said, past integer greater than 100 means 100 above. Integer must be like not decimal value. 101, 102, like that it will be going on. Okay. So that is also what actually infinite. This is what actually infinite. This is what a infinite set. Understand? And fifth one, set of prime number less than 99. See, less than 99 means that 99 below. We have 25 prime numbers. We have 1 to 100 in the sense 25 prime numbers. That is countable. Countable means finite set. You don't want to write what all elements we have in the set. We asked finite or infinite. They didn't ask to write element which is in a set. So you don't want to write all 25 prime numbers. Just finite or infinite. Suppose last term is there, na, we have to say finite. Okay, this is finite. And first one is finite. Other two, what I gave, infinite. Understand? Right, let's start the next Roman. That is third Roman. State whether each of the following sets are finite or infinite. Again, like a second Roman only they gave here. Okay, second Roman, like a second Roman they gave. Right, set of lines which are parallel to the x-axis. See, if you are drawing lines which parallel to x-axis in the sense, we can draw many. This is not a countable. We can draw many. So this will be infinite. What, my dear? Infinite. Many lines you can draw which parallel to the x-axis. Raja, if this is the x-axis in the sense, we can draw many lines here that all parallel to the x-axis only. Okay, that all parallel to the x-axis. So that will be infinite. Set of letters in the English alphabet. English alphabet, we know that letters are countable. 26 letters are there. So that will be coming under the finite. Okay, that will be under the finite. That's it. And set of numbers which are multiple of 5. Multiple of 5 means that will be 5, 10, 15. So that it will be going on. No end. No end means what we have to give? Infinite. No end means what we have to give, ma? Infinite we have to give. Okay, be careful. And the fourth one, set of animals living on the earth. On the earth, how many type of animals we have, we know. There is some count. The forest department or what is that, health department, they have some count in animal. In the earth, how many animals, how many types of animals we have. Every count they have. Okay, so that is a finite. What, my dear? That is a finite. In the planet, how many animals we have? Surely they have a count. And the last point, the set of circles passing through origin. Passing through origin. How many? Set of circles passing through origin. Through origin, we can draw many circles. No. See, there is a origin. This is origin, pa. through origin you can draw many circle you can draw. Surely infinite number of circles you can draw, infinite number of circle you can draw, so that is also infinite. What, my dear? Infinite. Understand? Right? Fine. See, this is, don't want to explain many with lengthy answers. Final answer, if you know very well, directly you can write like this. Right? Fine. Next, what I'm going, fourth Roman, but here there is a steps need, I think I gave space here. Whether A equal to B or not, in the following state whether A equal to B. Two sets are equal or not. Equal sets definition we have seen, right? That we have to check here. Okay, so that A, set A equal to, they gave A, B, C, D. A, B, C, D, they gave 4 elements. Same manner A, B, C, D. Here also 4 elements. So that yes, A equal to B, because the element A contained what? All, everything in a B. Okay. So all the elements in A which is in a B also. If you want to write, you can write. Right? Fine. Here, this is what? 4, and here also 4. 8, here also 8. 12 is not there. 12 is not there, na? We have to write A not equal to B, because number 12 and 12 alone, 12 does not belongs to B. Okay, that should be equal. Even though 18 also not here, 18 also not here, and 18 does not belongs to A. These numbers are missing. If it is there now, we can say that will be what? Equal. Understand? Right? Fine. Be careful. So equal in the sense, same number must be there in a given set. Now in the following, same only, A and B are equal or not. So this is 2, 4, 6, 8, 10 they give. B equal to, they said positive even integer and less than or equal to 10. Then B set can be what, ma? B is a even positive integer, less than or equal to 10, na? Even positive. That means starts from 1. But even means 2, 4, 6, 8, 10. They said 10 equal. Okay, x less than or equal to 10. Then 10 also included. The same number only they give, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. So that yes, A and B are equal. A and B are equal because elements, whatever we have in A, same elements we have in a B. If you want to write, you can write in the sense. Okay, all elements of A we have in a B also. Like that, if you want to write, you can write, not an issue. And next, fourth Roman, fourth subdivision. X is multiple of 10. What, my dear? X is multiple of 10. Then set A equal to 10, 20, 30, and it's going on. This is the A, set A. X is multiple of 10. That is an infinite set. One more point. And B also, what is that? Infinite set. But point what they gave 10, 15 and all they gave. 15 never come here because this is multiple of 10. 25, 30, it's going. 25, 30, it's going. So it never be equal. A and B are not equal because some numbers are missing in a A. Okay, some numbers are missing in a A. That you can write because 15 and 25 etc. These things does not belongs to A. These things does not belongs to what, my dear? A. So that which is not equal. Understand? Just go slowly. You will be getting idea whatever I am giving. So next Roman, what is that? Are the following pairs of sets equal? They gave question mark. Give reason for your answer. They asking. So there is a set. Okay, 2 and 3. X is solution of this. This. So we have to simplify that. You can take I factorization. Coefficient of x square 1. 1 into 6 means 6 only. There is a 5. 2 3s are 6. 2 3s are 6. When you add, you will be getting 5. So how you will be getting this? X plus 2 equal to 0 and x plus 3 equal to 0 and x is equal to minus 2 and x is equal to minus 3. So that B is equal to, what is our set? Minus 2 comma minus 3. So but A is given plus 2 comma plus 3. Is that equal both? Surely not. So that therefore set A and B are not equal because here negative terms we have, here positive terms we have. So that this is a not equal. Have you understand pa? Next we are going second question. Second question what? In the fifth Roman, second question same only. X is a letter in the word follow, they give. FOLLOW. First you should write as a set. Set A is equal to, when you write roster form, elements should not repeat. So first F I'm writing, F, comma, what is that? O let be, and follow means there is a double L. Double L you can write one time, enough, one time. One L you can write. O also already I have mentioned here, and W. Elements should not repeat when you write a roster form. Be careful. And set B equal to, they gave hulf. Hulf. Y is a letter in the word hulf. So W is there, O is there, L is there, F. No letter here repeat. So you have to check whether we have equal, terms are there. Not equal terms, same number of terms exactly. W, W, O, O, L, L, F, F. No terms extra. Exactly same number of terms we have in both set A and B. Therefore, set A equal to set B. Why? Because same elements only we have in the set B also. Okay, that's it. Next we'll go pa. What is that? Sixth Roman. Sixth Roman, what they are telling? From the sets given below, select equal sets. What all? See, they are given many sets. A set, B, C, D. D is here. D, E, F, G, H. So many sets they gave. They asked to check which are equal sets. They are asking which are equal sets. 2, 4, 8, 12. Is that anywhere else? 2, 4, 8, 12. 2, 4, 2 is missing here. Okay, that you leave it. Okay, then A is not equal to anything. This you take 1, 2, 3, 4. Yeah, here 1, 2, 3, 4. So B set and D set equal. Anything else? You'll say 1, 2, 3, 4. Yes, B set and D set equal. And this one 4, 8, 12. No, it's not coming. And this one plus 1 comma minus 1, minus 1 comma plus 1. Then set E is equal to set G. Anything else pa? Here 1, that is A. Okay, not. That's it pa. So these two are equal sets. These two are equal sets. Very simple ma. Same, exactly same element if we have in both the set, that is called equal sets. Okay, equal sets. Very important. Right, children? I hope that's it. Yeah. Exercise 1.2 over. Children, if you want a more video from our YouTube channel, means kindly share this and subscribe, like the video. Thank you, children. Take care. Bye. See you later in the next video.